In many games, we have to use some sort of physics, meaning any form of physical bodies that are able to collide with each other or are influenced by gravity, for example. In SpriteKit, we can use two amazing classes which make our work so much easier. The first one is called Physics World, where we don't have to create any physics world objects. We can use the physics world property of our scene, where we simply can define the gravity, for example, which is usually done as a vector. But we can technically have gravitation in the x direction, meaning left and right, as well. The default value for the gravity property is x 0.0 and y negative 9.8, which correlates to the gravity of the Earth. The other properties of physics world are rarely ever changed. So let's move on to the SKPhysics body class. Nodes have a physics body property, which we can add a physics body object to. If a scene is rendering a new frame, there will always be a physical simulation, which then calculates things such as gravity, friction, or collision with other physics bodies. Afterwards, we refresh the positions of the nodes and their corresponding properties. There are two different types of physics bodies. Volume-based physics bodies, which we use to represent objects that have mass and volume. We then use the is-dynamic property to decide whether or not this body is affected by gravity, friction, and other physics bodies. Edge-based physics bodies don't have volume nor mass and are not affected by any other physical elements. Based on this, there are three possible physics bodies we can create. A dynamic volume that is affected by other things that we can use to create physics bodies that can interact with other physics bodies and are also able to move. A static volume that is unable to move by itself but still is able to interact with other physics bodies. Or an edge, which is a static body with no volume. Edges are never moved and their mass is irrelevant, which is why we often use them for the physical ground of a game, for example. Physics bodies can be created a few different ways. You can create anything from a simple circle to physics bodies consisting of complex paths which follow the exact outline of a texture or body. But you should always keep in mind that the more complex a physics body is, the more computing power will be required to calculate it. Therefore, I usually suggest that you make your physics body as close as possible to the original graphic without overdoing it. Now let's talk about a few properties that we can set for our physics bodies. Mass defines the mass of a body and therefore how it will be affected by gravity and force. Friction defines the friction and will be defined anywhere from 0 to 1.0. 0.0 means no friction at all, and 1.0 is maximum friction. Linear and angular damping is being used to simulate friction when moving a physics body, whereas we use friction when we are dealing with two physics bodies. You could use this, for example, to simulate different environments such as underwater, air, or maybe even wind by defining values anywhere between 0.0 and 1.0. Restitution defines how much energy a body retains after colliding with another physics body, meaning how bouncy it is. If you set restitution to 0.0, the physics body will not bounce back at all. And if you set it to 1.0, it will bounce back with the same force that it had when it collided with the other body. Is dynamic defines whether or not the body is affected by force. A special case is affected by gravity, where we can define whether or not a body is affected by gravity. Allows rotation defines whether or not a body is able to rotate by force. And now we'll have a look at how physics bodies can affect our scene.